For our next problem on our review, we will reduce a fraction. Anytime you have a complicated fraction or one with variables, it's good to go to primes. So on this side, we'll go to primes. For 12, we could do 4 times 3, and 4 gives us some 2's. And 3 is a prime. So we have 2 times 2 times 3 times x times y for our numerator. For 16, we have 4 times 4, and the 4's gives us 2's. So we have a lot of 2's, 4 2's, and we have an x. Once you have all products, you're allowed to divide out common factors. So our 2 matches up, and another 2 matches up. That's all of the numbers we can take out. We can't take any more 2's because there's no more 2's in the numerator. Can't take the 3 because there's no 3's in the denominator. We can match up the x just like we did the numbers, and then we'll put back together what we have left. On the numerator, we have a 3 and a y. It should stay on the numerator. On the denominator, we have 2 times 2, which gives us 4. So we have reduced to lowest terms. Next, we have a multiplication of fractions, and this is where we try to cancel or divide out any common factors on the diagonals. So we check on this diagonal, and we do have a common factor. 2 divides into each piece. So we'll divide by 2. 2 will divide into 2 one time, and 2 will divide into 4 2 times. We'll check the other diagonal. The only thing in common is 1. We won't bother to divide by it because it doesn't make anything smaller. Then we will multiply across the numerators and the denominators. So 1 times 2 is 2 on the numerator. 1 times 5 is 5 on the denominator. And 2 over 5 does not reduce. For problem 25, we have division, and it has one fraction. The first thing I would do is I would make them both look like fractions. So we'll change the 6 to 6 over 1. That would make it look like a fraction. For division, it takes one extra step more than a multiplication. We're going to change to multiplication and invert the divisor. Or you may have been taught multiply by the reciprocal, which means flip it over. First fraction stays the same. We're changing to multiplication, and we're inverting the divisor. So it's going to be 1 over 6. Now it's the same rules as the multiplication. Check your diagonals for any common factors. On this diagonal, we have a 3 that is common. 3 will divide into 3 one time, and 3 into 6 will go 2 times. The other diagonal, only a 1, so we won't bother with it. Then we'll multiply across. 1 times 1 is 1. 4 times 2 is 8. And 1 over 8 will not reduce. Next, we'll look at addition and subtraction of fractions. For addition and subtraction, you have to have a common denominator. So that will be our first job, is to find the smallest thing that both of these denominators will divide into. I always check the larger denominator and see if it will work. Will the 4 go into 8? It will, so we can use the 8. So our least common denominator for this problem will be 8. So we want to get an 8 underneath. I'm going to bring down what I have. And I want to change this 4 and get an 8. So I would need to multiply by a 2. If you multiply by it on the denominator, you have to do the same to the numerator. So this gives me 2 over 8. My second fraction has the 8 already, so I can just bring it down. Then your rule is keep that common denominator, put it in the answer. Combine the numerators, they're both positive, so we just add, keep it positive. And 5 over 8 will not reduce. 5 is a prime, and it doesn't go into 8. For our next problem, we have to do a little bit more work to find the least common denominator. So we do need a common denominator. 8 doesn't go into 12, so we're not going to be able to use a 12. We can use the multiple method, or we can go to primes. I'm going to go ahead and do primes since we have one variable. So if we break an 8 to primes, 8 gives us 2 times 4, and then some more 2's. And if we do 12, we can do 4 times 3, and 4 gives us 2's and a 3. And we also have an x that we have to cover. Right? So we have to take every kind of factor that we have, and you take it from the one where it occurs the most. So we need 2's, 3's, and x's. Our 2's are the most in the 8, so we're going to need 3 2's. Our 3 occurs the most in the 12, so we will need 1 3. And our x occurs the most in the 12x, so we will need 1x. Multiply that back together, gives our common denominator. So 8 times 3 is 24x. That is our LCD. You also could have done multiples of the 12. Just remember the x. So get your LCD. This is what we want underneath. So I'm going to bring down what I have and put on the missing parts. So if I have 8 on the denominator and I want 24x, first for my number, it's missing a factor of 3. It is also missing the x. So I have to multiply by 3x. Numerator and denominator. We'll bring down what we have on the second fraction. Right. For our numbers, I have 12, but I want 24. So I'm missing a factor of 2. This one already has the x, so I don't need to put another x. Now we'll clean these pieces up. So I have 3x over 24x plus 14 over 24x. My rule is keep that common denominator. So we're going to keep the 24x and combine the numerators. 3x plus 14. These are not like terms. The only thing you can do is write them on the same line. And this does not reduce. You're not allowed to take a piece out if there is a sign in between. For 27, we're subtracting fractions. It is the same rules as addition of fractions. So we have to find a common denominator. Check your largest denominator. Does the 9 go into 18? It does. So we will use the 18 for our LCD. That can save you some work, right? We'll bring down our first fraction. 4 over 9, and we'll put on the missing part to get the 18. So this one needs to multiply by a 2, do numerator and denominator. We'll bring down our next fraction, 3x over 18. This one already has the 18, so we don't have to do any work on it. So we have 8 over 18 minus 3x over 18. You have the common denominator. Keep it, put it in your answer, and combine the numerators. You have to be careful because they're not like terms. One has x, one does not. All you can do is write them on the same line. You're not able to reduce here the 8 and 18 even though they have a common factor of 2 because of the minus sign in between the terms on the numerator. It would have to be a product to take off a part. For our next problem, we are subtracting fractions. So first we worry about a common denominator. These denominators are totally different. We have a 7 and we have an x. With the prime method, they're already prime. We would need both of them. So our LCD is going to be 7x. So for the first fraction, we'll bring down what we have. Check the denominator to see what's missing. We have a 7. We want 7x. So we'll have to put the x on. It's missing. For the second fraction, we'll bring down what we have. This time on the denominator we have x, but we want a 7x. So we're going to have to put the 7 on. Also do it to the numerator. Now let's clean those up. So we have 2x over 7x minus 35 over 7x. Now we have a common denominator. We will keep it, put it in the answer, and combine on the numerator. You have to be careful. These are not like terms, so all you can do is write them on the same line. 2x minus 35. Again, we can't reduce because of the sign in between the terms on the numerator. We'll look at one more fraction problem on this video. Evaluate negative 1/3 to the third power. The exponent means that you have 3 copies of this base. So we have negative 1/3 times negative 1/3 times negative 1/3. So all multiplication. First of all, we can deal with the signs. We have 1, 2, 3 negatives. That's odd, so it's going to be negative. There's not any simplifying we can do on the diagonals. We only have 1s and 3s. Nothing in common. So we'll just multiply across. Across the numerators, 1 times 1 is 1, times 1 is still 1. And across the denominators, 3 times 3 is 9, times 3 is 27. And this will not reduce. It doesn't matter where you write the negative. You can write it on top, out in front, or even on the bottom. But it is going to be negative.